The steel enters the rollers glowing brighter than the sun. At 10 to 100 degrees Celsius, the slab moves through the mill trailing sparks, smoke, and liquid fire across the factory floor. The rollers scream loud enough to drown human voices completely. Grease burns in the heat. Air trembles above the machinery like the inside of an oven, large enough to swallow buildings. And somewhere inside the smoke, men are still working. You see them only for seconds at a time. Dark silhouettes moving beside red-hot steel sheets, hundreds of feet long, faces hidden beneath soot and steam. Bodies bent forward against so intense it dries sweat before it reaches the skin. Some workers spent decades inside rolling mills like this, until their lungs blackened, their hearing vanished, and their skin carried permanent burn scars from flying scale and molten fragments. The mill never stopped long enough to care, because the rolling mill became one of the most important industrial machines ever built. It fed railroads, warships, skyscrapers, factories. Entire nations rose around steel production because modern civilization required endless quantities of rolled metal strong enough to build the 20th century itself. And to produce that steel at industrial scale, the mills consumed heat, electricity, coal, and human bodies without pause. Inside some factories, workers called the mills ghost makers, not because men disappeared instantly, because the smoke swallowed them slowly, shift after shift, year after year, until all that remained at the end of the production line was another exhausted figure walking out of the haze covered in soot, ash, and furnace dust, like a human shadow burned into the factory itself. And the hotter the mills became, the more invisible the workers inside them started to feel. Before the rolling mill, steel moved slowly, too slowly for the industrial world being born around it. Iron existed everywhere in the 19th century, in rails, bridges, tools, ship hulls, factory frames, and weapons. But shaping large quantities of metal into uniform industrial material remained painfully inefficient. Early blacksmithing methods depended heavily on individual labor. Heated metal was hammered manually into shape by crews working beside furnaces hot enough to blind workers temporarily through radiant glare alone. Everything depended on muscle, and muscle had limits. Large iron bars required teams of men swinging hammers in coordinated rhythm for hours at a time. Plate production for ships and boilers became especially brutal because thick sections of heated metal cooled rapidly once removed from the furnace. Workers had only minutes to shape the material before it hardened beyond workable temperature. The metal fought back constantly. At forging heat, iron glowed orange-white and shed flakes of burning scale into the air. Sparks exposed skin. Steam erupted when overheated tools struck damp surfaces. Entire workshops shook beneath repetitive hammer impacts, while smoke from coal-fired furnaces thickened the atmosphere until breathing itself became labor. And still industry demanded more steel. Railroads expanded across continents during the 19th century, faster than traditional forging systems could supply rails. Steamships required enormous quantities of rolled plate strong enough to survive ocean pressure and naval warfare. Cities rising vertically through industrial expansion needed structural steel beams in unprecedented volume. Civilization was beginning to consume metal the way furnaces consumed coal. The older methods could not keep pace. Every major industrial system now depended on standardized steel components, produced rapidly enough to feed factories, railways, mines, ports, bridges, and eventually modern warfare. In some industries, delays in steel production slowed entire national economies because construction projects waited for material factories could not shape fast enough. The bottleneck became shaping itself. Making steel was difficult, but shaping steel at industrial scale was worse. That is why the rolling mill became inevitable. Engineers realized heated metal could be compressed mechanically between rotating rollers instead of hammered repeatedly by hand. In theory, this allowed large steel sections to be flattened, stretched, and shaped continuously with far greater speed and consistency. But early rolling systems introduced terrifying new conditions. The rollers had to survive enormous pressure while operating beside furnaces hot enough to soften metal itself. Steam engines powering the machinery generated violent vibration across factory floors. Heated steel entered the rollers glowing nearly white, while workers guided it manually using hooks, tongs, chains, and brute force. The process resembled industrial combat. If the steel entered unevenly, it could whip sideways with enough force to kill instantly. If rollers jammed, pressure built catastrophically inside the machinery. Entire crews worked inches away from metal hot enough to ignite clothing on contact, and the mills kept growing larger, because industrial civilization kept demanding more steel. By the late 19th century, nations were competing directly through industrial output. Rail infrastructure determined military mobility. Shipbuilding determined naval power. Steel production became inseparable from economic dominance itself. Countries capable of producing enormous quantities of rolled steel rapidly gained advantages in construction, transportation, manufacturing, and warfare simultaneously. Factories transformed into steel ecosystems. Blast furnaces fed converters. Converters fed rolling mills. Rolling mills fed rail yards, shipyards, and industrial cities, expanding outward continuously. The machine was no longer simply shaping metal. It was shaping modern civilization. Inside the mills, labor conditions deteriorated as production intensified. Workers operated in temperatures capable of causing heat stroke year-round regardless of season. Air filled with coal smoke, metallic dust, lubricating oil vapor, and burning scale stripped from hot steel during rolling operations. You inhaled the factory constantly, and the work itself became brutally repetitive. Steel slabs weighing several tons moved across rollers continuously, while crews synchronized every motion to avoid catastrophic accidents. Timing mattered because metal cooled rapidly after leaving the furnace. Delays ruined production batches. Mistakes destroyed equipment. Entire shifts revolved around maintaining uninterrupted flow between furnace heat and rolling pressure. The mill could not stop easily once operating. That made workers expendable. Factories often operated 24 hours a day using rotating labor crews. Because shutting down large rolling systems wasted fuel, disrupted production schedules, and damaged equipment through thermal cycling. Men entered the mill before dawn and emerged hours later covered in soot so thick their faces appeared gray beneath the factory dust. Some workers barely saw daylight during winter months, and still the demand for steel increased. Skyscrapers began rising in American cities. Rail networks expanded through Europe, Russia, and Asia. Armies demanded artillery, armor plate, locomotives, and ammunition at scales previous generations could barely imagine. Steel became the bloodstream of industrial civilization, which meant rolling mills became industrial organs pumping shaped metal into the modern world continuously. The hotter the mills became, the more dangerous the labor grew. Early factories lacked serious ventilation. Heat accumulated beneath steel roofing until interior temperatures became nearly unbearable during summer production peaks. Workers collapsed from exhaustion beside machinery, powerful enough to crush bodies instantly if concentration failed for even a moment. And concentration always failed eventually. Because no human nervous system was designed to spend decades beside furnaces glowing at 1,200 degrees Celsius, while giant rollers screamed beside your head day after day. But the individuals accepted the cost, because the alternative was stagnation. Without rolling mills, there would be no modern rail systems at industrial scale, no skyscraper skeletons, no mass-produced steel plate for warships, no pipeline networks, no industrial expansion capable of feeding the 20th century. The machine had to exist because civilization had already become dependent on quantities of steel impossible to produce safely by older methods. And once the rolling mills proved capable of feeding that hunger, the factories only became larger, hotter, louder, and more relentless, until entire generations of workers disappeared into the smoke surrounding the machines that built the modern world. The rolling mill emerged because industrial civilization was running out of time. By the middle of the 19th century, nations understood something terrifying about modern industry. Whoever controlled steel production controlled the future. Railroads, naval fleets, bridges, artillery, skyscrapers, mining systems, pipelines, and factories all depended on enormous quantities of rolled metal produced with speed previous generations could not imagine. Iron alone was no longer enough. The world wanted stronger steel, longer rails, larger ships, taller cities, and it wanted them continuously. The earliest rolling systems appeared in Europe during the late 18th century, primarily for softer metals and smaller-scale iron shaping. But these early mills were limited. Roller strength, power transmission, and furnace technology could not yet sustain the extreme temperatures and pressures required for true industrial steel rolling. Then industrial metallurgy accelerated everything. Henry Cort's puddling and rolling processes in Britain demonstrated that mechanized rolling could replace slower hammer forging methods for certain iron products. Suddenly, heated metal could move through rotating cylinders repeatedly until it emerged thinner, longer, and more uniform than manual methods allowed. This was revolutionary. For the first time, metal shaping became continuous rather than purely manual. Factories expanded rapidly around the concept. Britain's railway explosion during the 19th century created enormous pressure for standardized rails capable of supporting locomotives, heavier and faster than anything earlier transportation systems had encountered. Traditional forge methods simply could not supply enough material. Rolling mills solved the crisis. Soon, entire industrial regions reorganized themselves around steel production. Sheffield, Pittsburgh, Essen, Magnitogorsk. These cities became furnace landscapes where coal, iron ore, rail systems, and rolling mills fused into gigantic industrial ecosystems feeding national expansion. And every decade, the mills grew hotter. The invention of the Bessemer converter in the 1850s transformed steelmaking entirely by allowing molten pig iron to be converted into steel rapidly through controlled oxygen flow. Later, open hearth furnaces and basic oxygen processes expanded production further still. Suddenly, the bottleneck shifted again. Now the problem was no longer producing steel. It was shaping the unimaginable quantities factories could suddenly create. Rolling mills became the answer. Massive steam-powered mills evolved into electrically driven systems, capable of exerting crushing force through multiple rolling stands arranged in sequence. Steel entered the first rollers thick and glowing, then passed through repeated compression stages until it emerged as rails, plate, sheet metal, beams, pipes, or structural sections ready for industrial use. The machine turned heat into civilization. Railway expansion depended on it first. By the late 19th century, nations were racing to construct rail systems across entire continents. The United States alone required millions of tons of rolled steel rails to connect eastern industrial centers with western territories. Russia expanded rail networks across impossible distances. European empires linked ports, mines, factories, and military infrastructure through steel tracks produced inside roaring mill complexes operating day and night. Without rolling mills, industrial geography itself would have remained smaller. Then naval warfare accelerated the pressure even further. Wooden fleets disappeared beneath the rise of steel warships, requiring armor plate thick enough to survive artillery bombardment. Rolling mills capable of producing massive steel sections became military assets directly tied to national survival. Britain, Germany, Japan, and the United States invested heavily in advanced steel production because industrial war depended on metallurgical supremacy. The rolling mill became strategic infrastructure, and the factories surrounding it became industrial fortresses. Workers entering major steel complexes during the early 20th century often described them as artificial landscapes rather than ordinary workplaces. Blast furnaces towered over entire neighborhoods. Rail lines moved continuously through factory yards carrying ore, coal, and finished steel products. Smoke blackened the sky permanently above some industrial regions. The mills themselves sat at the center of all of it. Inside, heat dominated everything. Furnaces operating above 200 degrees Celsius fed glowing steel slabs directly into rolling stands powered by steam engines or giant electric motors. Some rolling systems stretched hundreds of feet long while processing material continuously at speeds fast enough to kill workers instantly if timing failed. And timing often failed. But industrial demand kept overriding safety concerns. During both World Wars, rolling mills became engines of total war production. Factories produced steel plate for tanks, warships, artillery, rail systems, aircraft infrastructure, and military logistics at unprecedented scale. Governments pushed mills beyond normal operating limits because steel output directly influenced battlefield capability. Workers became extensions of the machine. Entire generations spent their lives inside furnace heat severe enough to cause chronic dehydration, respiratory damage, hearing loss, and nervous exhaustion. Yet many industrial regions depended so completely on steel production that shutting down mills became economically impossible. The machine consumed labor and nations simultaneously. By the mid-20th century, rolling technology evolved into continuous hot strip mills capable of processing steel almost without interruption. Steel slabs entered reheating furnaces and moved automatically through sequential rolling stands there where thickness reduced gradually under extraordinary pressure. The process became faster, hotter, more efficient, and more psychologically brutal. Workers no longer controlled the pace of production directly. The mill controlled them. Shifts revolved entirely around maintaining uninterrupted throughput because stopping continuous rolling systems wasted enormous amounts of fuel and damaged thermal stability inside the machinery. Men synchronized themselves to conveyor timing, roller speed, furnace cycles, and production quotas imposed by managers far removed from the heat itself. Inside the smoke, workers became nearly invisible. That invisibility mattered politically. Industrial nations celebrated steel production as proof of progress, power, and modernization. Photographs showcased glowing furnaces and endless rails stretching toward the horizon. But the labor sustaining those images remained buried inside the haze surrounding the mills themselves. Some workers spent decades without escaping the factory environment fully. Coal dust followed them home. Burn scars accumulated gradually. Hearing disappeared beneath the constant mechanical scream of rollers compressing steel under thousands of tons of force. And yet civilization continued demanding more. Because by then the modern world had already locked itself into dependence on mass-produced rolled steel. Cities rose upward because mills produced structural beams cheaply enough to support skyscrapers. Highways expanded because rolling mills supplied bridge sections and reinforcement steel continuously. Pipelines crossed continents because mills shaped endless cylindrical sections from furnace-heated plate. The rolling mill became one of the hidden engines beneath 20th century civilization itself. A machine so essential that entire economies accepted the smoke-swallowing workers around it as simply part of the cost of progress. The rolling mill worked by forcing steel to obey pressure stronger than the metal itself. Everything inside the system revolved around heat, timing, and compression. If even one failed, the mill became lethal instantly. The process began inside the reheating furnace. Steel slabs weighing several tons entered chambers operating near 200 degrees Celsius. hot enough to soften the internal grain structure of the metal until it could deform under pressure without cracking apart. Inside the furnace, the slabs glowed orange-white beneath combustion flames fed by coal gas, oil, or later natural gas systems powerful enough to consume entire trainloads of fuel continuously. The air itself became dangerous. Heat radiated outward hard enough to blister exposed skin within seconds. Workers standing near furnace doors often wrapped cloth around their faces because breathing directly into the thermal exhaust felt like inhaling from an oven. Sweat evaporated before reaching the floor. Then the steel moved. Massive mechanical pushers forced the glowing slabs toward the rolling line where the real violence began. The rollers themselves were giant hardened steel cylinders mounted horizontally inside enormous mill stands weighing hundreds of tons. Electric motors, or earlier steam engines, transferred crushing rotational power into the rollers through gigantic drive shafts and gear systems vibrating constantly under load. The sound never stopped. Steel screaming against steel, motors growling beneath strain, steam hissing through pressure systems. The entire factory shook rhythmically as slabs entered the rollers, one after another. When the heated steel passed between the rotating cylinders, the gap compressed the metal instantly. Thickness reduced. Length increased. Internal grain structures changed under pressure. Sparks and burning scale exploded outward, while workers guided the material using long hooks and mechanized handling systems designed to keep bodies away from direct contact. But bodies never stayed far enough away. The mill demanded human presence constantly. Inside older factories, crews called rollers or catchers stood beside the line waiting to redirect steel as it emerged from each rolling stand. Timing had to remain exact because the metal moved fast enough to whip violently if alignment failed even slightly. A misfed slab could kill multiple workers in seconds. Some mills process steel through reversing systems, where the slab passed back and forth repeatedly between rollers, becoming thinner with each cycle. Others evolved into continuous hot strip mills, where the material moved through multiple rolling stands sequentially without stopping. The steel became almost liquid in motion. At full operation, glowing strips hundreds of feet long raced through the factory beneath showers of sparks and smokes, while cooling systems sprayed water against overheated components continuously. Steam erupted everywhere. Oil burned on contact with hot surfaces. Scale flakes, fragments of oxidized metal stripped from the steel during rolling, blasted into the air like shrapnel. Workers learned to read the mill instinctively. You could hear imbalance before seeing it. A change in vibration meant a roller bearing might be failing. A new metallic scream inside the line could signal improper alignment. Too much scale buildup created uneven pressure capable of damaging both machinery and steel quality simultaneously. The machine communicated through violence, and every component inside it existed under enormous stress. Rolling forces reached thousands of tons depending on the product being shaped. Structural beams for skyscrapers required different roller configurations than ship plate, rail steel, or sheet metal. Entire missile stands had to survive repeated thermal expansion and contraction while maintaining precise alignment under crushing mechanical load. Temperature control became obsession. If steel cooled too quickly, it hardened before shaping completed. If it overheated, internal structure weakened or surface defects formed. Entire production runs could fail because thermal conditions drifted slightly outside acceptable range. The mill balanced constantly between softness and destruction. Cooling systems worked almost as hard as the furnaces themselves. Water sprayed across rollers, bearings, and finished steel continuously because friction generated enormous heat during compression. Some factories circulated thousands of gallons every minute, simply to prevent catastrophic overheating. The smell inside the mill became unforgettable. Burning grease, coal smoke, wet steam, hot metal, oil vaporized by radiant heat. and underneath it all, the metallic smell of oxidized steel filling the air continuously. Visibility often disappeared entirely. Smoke and steam swallowed sections of the factory floor until workers appeared only as moving shadows beside the glowing line. That was where the phrase "ghost workers" emerged in some mills. Men disappeared into the haze during shifts until only outlines remained visible against the furnace light. The machine consumed identity gradually, and the physical rhythm never relaxed. You move constantly because standing still near the rolling line becomes dangerous. Steel slabs weighing several tons travel through the system at speeds capable of crushing bodies instantly if momentum changes direction unexpectedly. Hooks, chains, overhead cranes, conveyors, and rotating shafts surround you from every angle. Every movement must synchronize with the machine. The floor vibrates beneath your boots continuously. Your ears ring from the roar of motors and rollers. Heat dries your throat permanently. Flame scale burns through clothing like sparks from a welding torch. Some workers wore layers of improvised protection, but little truly shielded the body from the mill itself, especially during breakdowns. Because breakdowns turned the factory into industrial chaos. If a slab jammed inside the rollers, pressure built instantly throughout the system. Steel could buckle violently or shoot backward through the line. Roller failures sent fragments of hardened metal across the factory floor. Furnace explosions occurred when cooling systems failed or gas pressure destabilized inside combustion chambers. And yet the mill rarely stopped fully. Stopping cost money. Stopping disrupted supply chains. Stopping interrupted national steel production itself. So repairs often happened while sections of the factory still operated nearby. By the mid-20th century, automation reduced some direct labor around the rolling line. Mechanical manipulators, computerized controls, hydraulic positioning systems, and remote operation stations improved efficiency while distancing workers slightly from the hottest sections of production. But the heat remained, the smoke remained, the noise remained, and the machine itself only became larger. Some modern rolling mills stretch nearly half a mile long while processing millions of tons of steel annually. Entire cities still depend economically on factory complexes descended directly from the early furnace systems that transformed industrial civilization. Because once the rolling mill learned how to shape steel continuously at extreme temperature and pressure, the modern world reorganized itself around the metal pouring out the other side. The rolling mill turned workers into shadows long before it killed them. That was the real horror inside the steel plants. Not always sudden death. Slow disappearance. You enter the mill before dawn, and the heat hits first. Not ordinary heat. Industrial heat. A wall of furnace air thick enough to steal breath from your lungs before the shift even begins. Your clothes absorb grease and smoke almost immediately. The floor trembles beneath the rollers. Somewhere ahead, steel slabs glow bright enough to hurt your eyes through the haze. And by the end of the day, your body no longer belongs entirely to you. The mill takes pieces gradually. Hearing disappears first. Rolling mills produced continuous noise levels, powerful enough to damage the human nervous system permanently. Workers spent years beside screaming rollers, steam vents, overhead cranes, and giant electric motors until conversation itself became difficult outside the factory. Many older steelworkers learned to read lips because the sound followed them home long after shifts ended. Then came the lungs. Coal smoke, furnace dust, metallic scale, lubricating oil vapor, and airborne particulates filled the air continuously inside early mills. Ventilation remained poor in many facilities well into the 20th century because maintaining furnace temperature mattered more than worker breathing conditions. You inhaled the factory every second, black mucus, chronic coughing, burned throats, respiratory collapse decades later. Some workers called it carrying the mill inside your chest, and the heat never stopped attacking the body. Inside hot strip mills, Temperatures near the rolling line often exceeded levels safe for prolonged human exposure. Men collapsed from heat exhaustion while still working because production rarely slowed enough for proper recovery. Dehydration became permanent. Skin hardened from repeated burns. Flying scale embedded itself into exposed flesh like fragments from exploding metal. The mill marked people physically. Scars across forearms, burned hands. Faces darkened permanently by soot and furnace radiation. Entire generations of steelworkers emerged from the plants looking older than they truly were. Then there were the accidents. A misfed slab whipping sideways through the line. A worker dragged into rotating rollers. Steam explosions from failed cooling systems. Molten metal eruptions after furnace breaches. Inside some factories, death arrived so suddenly, workers nearby barely understood what happened before production resumed around the empty space. And production almost always resumed, because the rolling mill fed national infrastructure continuously. Railroads depended on it. Shipyards depended on it. Construction industries, pipelines, automobile factories, and military production all depended on uninterrupted steel flow. Stopping the mill carried economic consequences larger than individual lives. That reality shaped the psychology inside steel towns. Entire communities became economically trapped around rolling plants because the factories provided wages powerful enough to sustain cities while simultaneously destroying the people earning them. Families often worked across generations inside the same mills, despite knowing exactly what the labor would do to the body eventually. Fathers brought sons into the smoke because the alternative was poverty. During the industrial peak of the 20th century, some steel regions operated almost permanently beneath atmospheric pollution generated by rolling mills and furnace complexes. Rivers blackened with runoff. Buildings accumulated soot thick enough to stain entire neighborhoods. Factory smoke turned daylight gray above industrial cities across America, Britain, Germany, Russia, and Japan. The machine transformed landscapes as aggressively as it transformed workers. Then global economics began changing. By the late 20th century, many older rolling mills became economically unstable. Automation reduced labor requirements dramatically. Continuous casting systems eliminated some earlier production stages entirely. Foreign competition undercut aging steel regions dependent on outdated infrastructure and high labor costs. And slowly, the ghost factories began shutting down. Entire industrial cities collapsed around them. Pittsburgh restructured itself after steel decline devastated employment. Sheffield lost major portions of its manufacturing base. Soviet steel complexes deteriorated after economic collapse. Abandoned rolling mills stood empty beside rivers, once crowded with barges carrying ore and coal into furnace districts operating day and night. The silence felt unnatural after decades of noise. But replacement never fully erased the machine. Modern rolling mills still exist at enormous scale. Automated systems now use computerized controls, laser measurement, hydraulic positioning equipment, and enclosed operator cabins, reducing some direct exposure to heat and smoke. Yet the fundamental process remains almost unchanged. Steel still enters the rollers glowing near 1200 degrees. Pressure still reshapes the metal through force. Heat still dominates the factory, and workers still operate inside environments hostile to the human body itself. Only now, many of the old industrial districts survive mainly through memory and ruins. Abandoned mills stretch across riverfronts like rusted mechanical skeletons. Conveyor systems hang motionless above cracked concrete floors. Furnace towers stand empty against polluted skies, while weeds emerge through rail yards, once carrying molten steel across continents. The ghosts never fully left, because modern civilization still carries the shape imposed by rolling mills everywhere. The rails beneath freight trains, the beams holding skyscrapers upright, the steel skeletons inside bridges, factories, ships, pipelines, ports, and industrial cities. All of it passed through rollers somewhere. All of it emerged from heat so extreme human beings spent generations disappearing inside the smoke surrounding the machines that shaped it. That may be the final contradiction of the rolling mill. It helped build the modern world stronger, taller, faster, and richer than any civilization before it. But inside the factories where that transformation happened, countless workers became nearly invisible, long before history remembered what the machine actually cost them.